definitely a site I'm happy to see. I tell you, every time you do a survey for one of these conferences, the number one thing we hear back is we want more time to network. So I always talk to my board and my staff, and like, maybe we should just invite people and not put anything on, and they can just network for 4 hours and see if they like that. Our next session is on energy storage, and if we could have Alex and Brandon come on up, that'd be great. So when we look at energy storage, we look at in Missouri, we're in a unique position with the existing cost of energy and infrastructure, and that makes the perspective of energy storage a little different. But we are seeing renewable energy growth. We are seeing technological innovations increase rapidly, and we're also seeing affordability of these devices grow as the market grows. So, like the rest of the country, Missouri is home to a variety of energy storage pilot projects, establishing feasibility, reliability, and capacity data that will inform energy storage development in the years to come. So, we're hoping this session you'll learn about the growing market, these specific pilot projects in Missouri and from elsewhere, and get ideas and potential partners. Our first presenter today, Matt Rayford, Senior Technical Manager at the Consortium for Battery Innovation, will join us virtually. And then we'll have Alex Rojas, Director of Distributed Technology at Ameren, and Brandon Sack, the Clean Energy Development at Evergy. So thank you in advance, both of you, and ready to go.
Hi, everyone. It's a pleasure to join you today. Sorry I couldn't be there in person. Today, I'm going to talk about my organization a little bit, but about energy storage and energy storage materials in Missouri, and really how that fits together. And there's an untold story in Missouri that I think will be interesting to the participants of this meeting, and that's really focused on lead batteries, lead acid batteries. And many people don't know America's position in this market, the utility of this technology, and also state specifically how well positioned Missouri is in regards to this technology and how it's being used in energy storage systems. Now, some of the previous sessions focused on things like projects, tax credits, decarbonization, and other aspects. And the speakers in this session will focus on energy storage systems. I'm a battery guy, so I'll be talking about lead batteries today. You can go ahead and advance to the next slide. So CBI is a pre-competitive research organization for the lead battery industry globally. In terms of the entire global market, the lead battery industry represents over $50 billion worth of energy storage production, producing about 420 gigawatt hours batteries a year for various number of applications. CBI, like I said, is pre-competitive. We have over 110 members, split amongst America and Europe mainly, but we have a growing population of members joining from Asia. We also have select members from Australasia, Africa, as well as South America. So going to the next slide, you can see some of the member companies. Many of them I will talk about today. They actually have facilities in Missouri, but our membership comprises battery manufacturers, suppliers, materials producers, as well as end users. The next slide shows some of our partners, such as Ford Motor Company, Ameren, as well as national institutions like Argonne National Laboratory, the U.S. Department of Energy, and we have collaborative research projects across America, Europe, and other regions of the world. Moving to the next slide, I'll talk a little bit about CBI's outlook in terms of ESS. And for America, we speak openly with U.S. Department of Energy as well as EPRI, trying to understand all of these different goals between different federal stakeholders. So if we're looking at the slide, looking at ESS growth, really and truly across the entire world, there is projected double-digit growth in energy storage systems for utilities over the next 10 years, all the way out to 2030. Now, this figure was taken from the Energy Storage Market Report produced by the Department of Energy in 2020. They're constantly updating these kind of projections, but we're talking about hundreds of gigawatt hours of electrochemical energy storage getting moved into the utility sector. Of course, there's many different challenges to this, especially if you think about the entire picture, hybridizing with renewable energy. And the market is extremely immature, and there's a lot of work to be done on how to properly install these systems and link them up to an aging utility grid. But, you know, in terms of this specific growth area for battery technology, it's not only just happening in front of the meter, so on the utility side, but also behind the meter. So we're seeing these kind of systems popping up all over in residences, becoming standard and build outs for new neighborhoods, as well as behind the meter. So more of a commercial industrial type of application, almost doing things like demand reduction, tariff management. We think this is key also for movements such as EV fast charging stations. How do we alleviate pressure from rush hour traffic, from fast charging stations on an aging grid without drastic upgrades? And we think battery energy storage systems are very important. I'm partial to lead batteries, and I'll explain why in just a moment. But really, it's kind of an all hands on deck situation when it comes to energy storage systems. So looking at the next slide, so CBI has an active research program. We also develop technical roadmaps for lead battery technology. You can see here just the many different applications we focus on. So lead batteries are present in automobiles in different ways, some for SLI, also a micro hybrid. They're present in electric vehicles as an auxiliary battery for safety functions or for peripheral functions, say like backup cameras, infotainment, energy storage system, industrial applications like data centers, as well as telecommunications, motive power, so forklifts, golf carts, as well as applications such as e-bikes, e-scooters, which that's extremely popular in Asia. And just to touch a little bit further on ESS, if we look at the next slide, these are some of the goals of the technology. You'll see here that we have research programs with UCLA, as well as collaborative teams across the world, the University of Warwick and Loughborough University looking at smart management of lead batteries and ESS, Credential and EAI looking at residential systems, Hammond and East Penn looking at additives into the batteries, as well as Exide and ICMA in Spain, looking at lead batteries and ESS during operation and understanding failure. So for this next segment, I'll focus on really a snapshot of Missouri and try to educate you on why I think the show me state may want to be the storage state. There's quite a lot. So if we advance to the slide that is lead and lead battery industry. So the US footprint for the lead battery industry is about $27 billion. Now to put that in perspective currently, that's about half of this industry and almost a quarter by value of all energy storage being produced today. In terms of volume, it's roughly somewhere between 30 and 35% of all lead batteries are produced in America. But one thing to keep in mind is that Missouri is a really special state. There is a wide array of both lead battery manufacturers, but also recyclers, people in the supply chain, end users, research institutions, a whole spectrum. So some of the largest producers of batteries in the world all have facilities in Missouri, such as Intersys, in which they have a facility in Kansas City, and then outside in Warrensburg, as well as facilities down in Springfield through their North Star affiliate. They have 2 sites. There's also Clarios, up in St. Joseph, as well as Stryton Energy in Kansas City as well. But there's also Doe Run. So one thing about lead batteries that is special is their sustainability and recyclability. About 99% of all lead batteries are recycled. And this makes the supply chain very, very domestic. This is extremely important as build out of energy storage across not just utility services is being considered, but the demand is growing in almost every single application. So supply chain has become a very distinct conversation within this space. If you pay attention to any of the commodity materials affiliated with energy storage, there's been a heavy amount of speculation. And supply chain analytics, as well as national security concerns, are key topics from the federal government on how best to handle them, develop them, specifically towards other technologies like lithium ion. Lead batteries, because of their recycling profile and the amount of this recycled material going back into the battery, make it a very stable supply chain. It's domestic, as I said, very strong American infrastructure. And there's been advancements in the last 10 years that have made many types of lead batteries higher performing. Now, in terms of, if we advance to the slide that shows battery recycling, kind of walk through this just a little bit more. If you look at battery manufacturing, Missouri has this covered, but also the recycling itself. So Doe Run, formerly more of a primary miner, has a very large recycling operation in Missouri, and really helps it provide many of the materials that go into lead batteries across the nation. But within Missouri, the state produces everything from tank batteries to ESS batteries to automotive batteries to telecom and data center type batteries. And Missouri is definitely a net export state for energy storage. And over $2 billion industry is contained within Missouri. And so, you know, of all the states in the union, not many can boast such a strong infrastructure for domestic energy storage. And the lead battery and lead industry provides well over, you know, thousands of high-tech manufacturing jobs within the state. Now, I'll spend the next few moments discussing a few energy storage systems. I think Alex Rojas may discuss one of them, so I won't harp on it too much. And this is involvement that we've had with Ameren. So the next slide, looking at EV fast charging, 1 megawatt or buffer. So as I mentioned earlier, EV fast charging is fast becoming a concern for utilities. The amount of energy that's produced, that is needed by these systems can be quite high during high peak times. The other concern too is for, say, specific quote unquote gas station or charging station, you have to think about peak power demand, how to manage that, and to alleviate any concerns about going over an allotted demand at a given moment. So these kinds of behind the meter storage projects are really important to keeping the grid stable and also not causing very heavy penalties for a given station. So Ameren has been working on a project with the lead battery industry, looking at backing up one of basically a pilot charging station platform using lead batteries. You know, this is really focused on their own kind of fleet vehicles and how to use them appropriately, but also not stressing the local grid. The project itself, from an energy storage perspective, of course, is to alleviate some of this demand off of the charging stations, but also possibly provide more hybridized functions, as well as like what has been discussed in other forms of smart grid functionality. So how do we use energy storage locally to benefit not just a specific use, but a specific area? So things like backing up the local area around the energy storage system as well. Now, there's many different systems across the United States. I'll talk about two with the remaining time I have in Missouri. One is a multi-purpose energy storage system in Springfield, Missouri, through city utility there. It was established in 2018. It's about 2.5 megawatt hours of Northstar Blue Series AGM lead batteries. This is a Missouri battery made right in Springfield. System provides several functions: peak shaving and demand response, as well as in the case of inclement weather. I'm from Texas. My understanding is that Missouri has just an even crazier weather pattern in which you can have all 4 seasons in 1 week. Emergency backup is a very important concern for this system in case of a winter storm or other inclement weather event. This is also being managed by in-house battery management that was also developed within Missouri using ACE technology. This system has been operating for over 3 years now through city utility. And then the next slide, Missouri S&T has partnered with 2 institutions, 2 manufacturing companies, Northstar and Intersys, to produce a residential ESS system for their eco village, which uses a combination of solar power and energy storage to power 5 on-site houses for students at Missouri S&T. This has also been running for about 3.5 years. Using lead batteries, kind of demonstrating the fact that local domestic energy storage can fit some of these application needs within Missouri. Now, moving to the next slide, there is quite a few examples of energy storage systems using lead batteries across the world. I encourage you to go to our website, batteryinnovation.org, if you're interested in understanding more about the technology. I would just say that Missouri is quite a special case in which there is a incredible amount of infrastructure for both recycling of energy storage as well as the production of it. And there's really good examples of how that's being used within Missouri. I think that it's a really nice story showing that there's a lot of hardworking people in the state providing a very necessary function for the utility grid. So with that, I'm going to base the next slide and do a shameless plug. We are a global organization. If any of you can convince any of your management to allow you to go to France, I really encourage you to go to France in September to learn more about the lead battery industry globally, if you're interested. They'll be at ELBC, European Lead Battery Conference in Lyon. If you have any questions about that, feel free to reach out to me. And I thank you for your time.
All right. Good morning, everyone. Can everyone hear me in the back? Yes. Are you good? All right. My name is Alex Rojas. I'm Director of Innovation, Implementation, Strategy at Amherst Services. Appreciate the opportunity to share a little bit about Amherst projects around storage. I know we're running a little yeah. No problem. Rather not late, so I'll try to make this brief, showing you first a little bit of overview. I'll run through the deployments that are already in operation, what my team is doing right now, as well as what we have planned for the future. Most of you would be familiar with Amherst pump storage hydro location. Comstock, as you would know, water volume capacity 1.5 billion gallons, 8 hours duration at 40 megawatt power throughput is what the deep plate is for that facility. In 2016 and 18, my small team deployed two lithium-ion technology batteries in the state of Illinois. Both were integrated at the distribution level, at theater level, so they were utility batteries. About 1 megawatt hour is what their ability to hold energy is today because they're in operation. And their function has been to provide reliability and resiliency. The one that was integrated to a microgrid in Champaign, Illinois. The other one was a T connection feeding the town of Feeds, Illinois for resiliency. For a while, that town had been affected by animal contacts that were making energy flow not possible. So the battery brought both resiliency and reliability to the whole town. Ongoing now is this project that Matt introduced us just a minutes ago, and it's a advanced lead-acid battery pilot project. It's in downtown St. Louis. It's behind our headquarters. The use will be to support multiple business use cases for managed charging of EVs. As you may know, the fast charging EVs take a lot of energy, and that energy stresses the local network. And this battery is meant to demonstrate how it is that storage, and specifically lead-acid batteries, can support and alleviate that stuff. I'm looking at a potential economic impact on Missouri's lead production, as well as, of course, the recyclability of the technology. 98%, as all of you know. Nominal energy about 1.5 megawatt hours, and the nominal power output up to 1 megawatt. Okay. To this method, I am allowed to announce who is it that prevailed. We work with 3 vendors, and one has prevailed. I'm getting a text saying I'm not ready to get announced, but be aware. That's coming soon in the news, and it's part of almost a year process to see who is the vendor who will meet our requirements. In the future, hydrogen, as you can see, my team has proposed 2 major projects. One of them is basically using green electrons from already existing renewable sources like solar. And the biggest capability I am seeking to leverage is the long duration. Unlike lithium and lead-acid batteries, when you compress or store hydrogen in other means, you could have up to several days of support. So hydrogen is going to bring to our system that capability. Another site that we're pursuing would be a CNI site or similar, where hydrogen would provide use cases such as demand charge management, reliability, and as well as resiliency. This right picture happens to be an system installation in Champaign, Illinois. And they have an involvement other than producing the energy actually that this consumes. But I know this picture because I want to demonstrate that the technology already is there. Quite frankly, it's not yet economically viable, but you can order all these components to integrate and support a facility. In this case, is the Champaign Metro. Basically, they have 2 large hydrogen buses, more that fetch hydrogen from this facility. Yeah, I think that's it for me, and we're gonna take questions, I guess, after all 3 of us are done. Thank you.
Good morning. It's nice to see people in person. I get to wear real pants today. I'm very excited about that. I'm Brandon Stack. I'm with Evergy, and I get to talk to you a little bit about some of the things we're doing in our energy storage world. And I call it our energy storage world. It's our energy storage world. Just a quick overview of Evergy, and maybe even to tie in some of the earlier discussion. You can see the territories that we serve right now, and you look way out there to the west, and you see all kinds of wind resources. In the middle, all the typical fossil fuel resources that you see, sprinkled with a few wind resources, but that real wind corridor shows up there in the west. And this map maybe ties all of that together, and we can see why bringing interruptible renewables into our equation can be a bit of a challenge. Right through the Midwest, that's some of the best wind in the entire world. And we want to take advantage of that. There's only so much energy in the Midwest that's being used. It's used on the coast as well. So it's our way to get that wind, either bring load to the winds, or do we take the wind to the load? Solar as well. As you move up into Kansas and Missouri, there's still some good solar resource in our area, and that will continue to build out. But the best is in the Southwest. So yeah, do you take load to the renewable, or do you move it up? So maybe that leads into our energy storage portion. We'll talk about what we see as the benefits of storage, and a couple of pilots that we're working on in energy. On the left side of the screen, it talks about utility scale and customer scale, residential, commercial, industrial. There's really not many differences. They all do the same thing. I can take renewables and I can store them to use them later time. I can do that utility scale. I can do that in my home. I can stabilize my load, which is the same thing as shifting peak demand. So someone earlier discussed the flat load. It might have been a show. Maybe the ultimate goal is load looks like this. It's just completely flat, and use energy storage to create that kind of atmosphere. So base load becomes base load, and batteries work to fill everything else in. Microgrid and Blackstar, utility scale and residential scale. All of that to me is the same thing. We're solving it on macro through micro level. And I think the utilities can be a big piece of solving the entire equation. And it takes things like these pilots and discussions like this to help move all of that forward. You heard me talk about that in hydrogen before, some other technologies that we looked at. So pumped hydro has been around forever. It's one of the oldest storage technologies that we have on the utility grid. Compressed air. That's just shoving air into a big cavern and storing it for a later time. It's not super efficient, but it could be useful in certain situations. Flywheels, they've been around longer than anything. Batteries. Lithium ion is the one that's been discussed the most along the way. Iron flow. We haven't heard much about flow batteries, which is taking a longer term storage view. So lithium ion, very short term. The iron flows are trying to work out to 10 to 12 hours of storage just by flowing, charging electrons through fluid. Thermal energy storage. Have y'all heard about taking carbon dioxide, for example, heating it up and then heating sand up? Storing that heat energy in sand, for example, and when you need to utilize the energy, you let the sand cool down and it turns the generator. Sounds like it could work. There's people working on that technology right now, and they're reaching out for pilots across the US. And then we try to combine them all. So wind-powered pumped hydro. There's some pretty cool alternatives in Europe right now where the basin is concrete. And they actually store water inside the basin. So they'll pump it from the basin down below into the base of the wind turbine, and then when they need the energy, when the wind's not blowing, then it'll flow across the generator. Some really cool stuff going on out there. Non-conventional storage, well, almost anything can get considered storage. I can say that. Because really all we're doing is trying to use excess energy that we have right now, store it in something, and then use it later when we don't have that energy. Hydrogen's a good example. Create hydrogen when we have excess renewable energy. It is intermittent, we can't control it. So let's put it in hydrogen, it's something we can't control. And we can either burn it through a CT. As I mentioned later, we can put it into vehicles. There's all kinds of uses for hydrogen, ammonia as well. Superconducting magnets. Here's an example. So a theme park with a roller coaster. They have these superconducting magnets that store energy. And we used to go up in a chimney, but now they shoot you out of the gate. And that's a superconducting magnet behind it that's storing energy, and it's pushing you out of the gate. So now I'm not hitting peak demand. I'm not hitting the utility grade for that peak. And I'm doing a slow drop, and those pulses come straight out of that storage device. And the cranes, these are my favorite. These cranes have 6 to 8 arms, and they pick blocks up when we have excess renewable energy, stack them up, and then when the wind stops blowing, we start dropping blocks and we get energy out of these cranes. I don't know if in the US they're built, but I think there's a pilot in Europe that's currently testing this technology. So move to energy. What are some of the things that we're looking at? The first one is a proposed at state reserve right now. What we're really looking at is a 50 battery pilot to put into residential or small commercial customers. And we want to work with them to cover a couple of objectives, but really to understand how batteries can be incorporated at the residential level into the betterment of the utility grade, the distribution grade. That's really the goal. I mean, if we can't understand how it's going to work and we can't work together to get the benefits from everybody, then we may not have a solution for the future. So that's really something that we want to explore and develop. So we're really looking for 4 cases, maybe somebody with some solar. That way we can store excess renewables. Time of use, anyone interested in time of use? I think that's a big discussion around the entire country. If you're in a deregulated market, you already know time of use for the most part. But in these regulated markets, it's kind of a new concept. Electric vehicles, yeah, so we've seen a couple of presentations about that. And what about smart home appliances? I know when I go home from work, I turn on the stove, the oven, the microwave, start the washing machine, dishwasher comes on right after that. Maybe batteries can help us move that load into the evening when we have abundant renewable resources. So really, peak demand reduction may be something that we're really helping with these in-home batteries. Self-consumption of renewables. Right now, when we overbuild solar on our house, so we cover an entire month's worth of solar, we're really pushing power back and forth from the grid. We're pushing out when we're overproducing, and we're drawing from the grid when we're underproducing. So the battery can now take that excess, store it in the battery, and I've really flattened my curve out for the entire day. I haven't stressed the distribution grid. And power quality and reliability. It kind of speaks for itself. At the residential level, microgrids, that type of thing. If I can self-supply for even a couple of hours through a power outage, that can be the difference in somebody's livelihood. On the Kansas side, we do have a utility scale project. It's 1 megawatt. It's a 4-hour battery. Its main goal is to teach us how to deploy these into the SPP market on a day-to-day and real-time basis, and even the maintenance electric market. But it's also got a microgrid component to it. We're going to connect it to the zoo that's sitting right next door. So in cases when the distribution grid might go down, we're going to understand how to map it work in an island situation, keeping the critical infrastructure at the zoo going. And that's what's going on at Evergy. I appreciate everybody's time and look forward to the questions. Thank you.
All right, thank you all very much. Are there any questions for the panelists? Anyone up front?
There's a lot of ways to recycle batteries, and we're seeing more and more of that. That technology kind of continue to develop. But the big adoption that we're seeing in the market right now is EVs, cars, most notable Tesla. And usually in a car, the battery gets about 10, 15 years old. That battery becomes only about 70% of its capacity. So you use, not to mention you have some get an accident and what have you. Has there ever been any consideration to see if there isn't a recycling position where you can take some of those batteries that are at the end of a useful life from a vehicle and just repurpose them into some of your technologies to see if there's some synergy there, and that really reduces the, because generally I think, to my understanding, when you use battery technology on a grid, you're really only kind of using a certain percentage of that battery. You're not taking it all the way to 0 and all the way to 100, right? You're kind of playing with a 30% band here. Have you guys looked at kind of talking about ways to kind of hold those batteries and kind of accelerate your ability to build these projects?
I might have to pitch in here. So I'll summarize what you asked. The audio broke up just a little bit. So you're asking for electric vehicle packs if there's been efforts to repurpose still intact useful cells out of electric vehicles and apply them, say, into ESS. Is that a pretty good synopsis? I can give some comments to this.
Yes, that's what was asked.
Okay. Yeah, so it's quite complicated from an electric vehicle standpoint. If you think about the vehicle chassis itself, there's thousands of these cells along the bottom of the vehicle. Every producer of EVs does this differently. So at end of life, I think you said 70% capacity, which is a pretty fair estimate of how most producers treat it. How do you get the cells out? Currently, they do it by hand. Now, there have been cases of ESS where they basically take a car chassis and they put it up on its end, and that's a battery bank. There's really severe concerns about safety. So what do you do about thermal runaway on something like that? And whether or not it conforms to codes and regulations. So if you speak to any EPC that sets up these ESS, there's a legion of codes and standards that are being developed. So whether it's a secondary battery, lithium, or even lead, versus pristine, all of these things have to fit NFPA or international fire codes. Underwriters Laboratory does 9540. These are severe concerns. But the biggest concern for using electric vehicles, in my opinion, I've been in some of these recycling centers where they basically take vehicle battery packs, is the sheer amount of man hours to actually alleviate any of these cells, test them, all sorts of things. And then the paperwork involved with who has liability at the end of that is a nightmare right now. Lead batteries had to go through this recycling concern starting back in the 70s, and there was a massive amount of infrastructure set up, code standards, regulations to support and also monitor and put boundaries around that industry. There's an immaturity to other technologies right now, and it's playing catch up. That idea has been tossed around. I think there's some really nice demonstration systems, but some of the utility guys might be able to say the regulations, codes, and understanding of how to indoctrinate these into ESS is rapidly evolving. And that's kind of a hurdle and burden that the entire industry is trying to understand and make sure that they conform to if they have to. So it's a bit of a bear right now for really any electrochemical energy storage system.
Would either of you like to take an additional crack, or is that pretty good?
That's pretty good.
That's pretty good. All right. Any other questions? I'll take these two.
Thank you. My name is Mike Gordon. I'm from Acer Technologies in Joplin. And I had a question about the lead acid market. I know that lithium ion batteries, you hear about them all the time, and they're rapidly expanding markets with EVs and this. But I know that lead still has a huge market. So what do you see expanding in the lead market? What industries do you see that expanding into?
Yeah,
Matt, you want to go, or this is Alex?
go for it, Alex, and I'll fill in any blanks. That sounds good.
All right, yeah, I can address the telecom and energy market where I've been in my career. So advanced lead acid batteries are addressing worldwide highly cyclic applications, such as regions in the world that get daily blackouts or brownouts. There are telecom stations that lead acid batteries have been over the years designed to withstand several thousand cycles in their lifetime. Let me differentiate that market from the UPS market, which is the traditional decades-old market. In the basement of a lot of buildings at Ameren headquarters, we have several hundred of those in our basement that are only good for 200 or less cycles because they're standing by 3 years and they don't get exercise. So the new frontier, if I understand your question, is mostly the high cyclic application in ways that I just mentioned, as well as renewables, right? For renewables, wind or solar that comes and goes, you need at least 5-10 cycles a day to address that market. So it's a new frontier. The battery I've chosen already, but I'm not ready to announce it. It's a 5,000 cycle battery that is good for 10 years shelf life. So I'm very eager to demonstrate that to the industry and open that door for Missouri's economy.
Yeah, I think that's a really good snapshot. So just for perspective, lead batteries were used in everything from submarines to floor scrubbers for hallways. So it's a lot more heavily segmented market versus some of the other energy storage technologies. Key areas of growth that we see, so along the lines of what Alex said, so there's specific ESS applications. I use ESS basically for front of the meter and behind the meter. So things like C&I, so how a specific business uses it, I think that market will grow and grow and grow as people start to understand how these kind of systems can really help them with their bottom line. We've heard from pharmaceutical companies all the way down to trucking companies that are interested in ESS. The other one that is really unclear is long duration energy storage. There's some pretty clear goals set out by federal stakeholders, but this is a huge burden. And we're starting to see some of these systems come online for batteries, and it's exciting to me. A lot of them are not lead, but it's still exciting. But there's a lot more learning to be done about that. I think specifically lead can be quite nice for that type of use. It likes to be charged slowly and can discharge slowly for a very long time. So the levelized cost of ownership can be quite low. But to step out of the ESS space, data centers are a huge growth area for lead batteries, really for many different batteries. Data centers are growing so rapidly that lead is supplying well over 90% of the demand, but lithium's coming in too. But we've seen double-digit growth in that sector alone just this past year. Similarly, telecom, as Alex remarked, 5G rollout from some of the big carriers is set up a lot of orders. And then there's things like outside of Missouri, say like the wildfire incidents in California, they're using batteries of all types to back up cell phone towers as kind of a auxiliary system for some of the extreme conditions they see. And then I mentioned this during my talk, auxiliary batteries. And this is a broad term, but this is basically a small 12-volt lead battery that's used in EVs, but also micro hybrids and internal combustion engine vehicles. So the lead batteries are kind of being spread throughout the car cabin in some instances. Like I said, to power things like infotainment and all the peripheral electronics. So just a statistic there, back in the 90s, there was about 25 individual electronics a lead battery might be powering or regulating. Now it's well over 150. So there's a lot of concerns. And really it's based around using lead batteries instead of the traction battery. So you get maximum range out of your traction battery. It's not powering or facilitating energy in non-traction applications.
Fantastic. If you all can join me in thanking Alex, Brandon, and Matt for their fantastic presentation.
Thank you.
Thank you. For those of you not aware, energy storage, mineral extraction, and energy storage development, that integration is part of the Missouri State Energy Plan. If you are interested in taking part in that, there's an opportunity with the Division of Energy. I'm really excited for our next presenter and our partner, Stephen Mills, the Vice President of General Manager of Spire, Missouri West, is here as a fantastic sponsor and will introduce our next speaker.